Hello, what's up everybody? This is video number 13 corresponding to question number 13 from a Physics C Mechanics AP multiple choice test. So the question we're looking at right now is a skier is traveling down a slope that is inclined 30 degrees above the horizontal. The coefficient of kinetic friction between the skier and the slope is 0.1. Which of the following best describes the acceleration of the skier? A, it is 0. B, it is about 4.0 meters per second squared. C, about 9. D, about 10. Or E, cannot be determined without knowing the mass of the skier. So this is one of those problems where you're going to want to have a diagram. You're going to, let's do that and then we'll talk about some more stuff. So here's our ski slope. We've got the 30-degree incline right here. That's our theta. I'm just going to draw a box instead of a skier because that's how most problems are with a box. Alright, so he's going to be accelerating down the hill, on the slope. This is our mass. And then we're going to have some kinetic friction. So I'm going to draw that right here. Force of friction. And here's our acceleration force. We're accelerating down the hill. It's getting close so we can all see the diagram. Alright. So for this one, we're going to want to sum the forces. So first we have to define what our axes are. So I'm going to call this the plus y direction, this the plus x direction, corresponding to this. So now we're going to sum the forces. So we want to know what the acceleration of the skier is. So we only really care about this direction. So let's write this out. So we also, let's go back a minute. We have mass times gravity pointing downwards. That's the weight of the skier. But since we've defined these axes, we're going to have to split this up so that it fits the axes that we've defined using sine and cosine. So redraw the free body diagram down here minus the slope part. So we have our mass. We've got the force of friction pulling it backwards. We've got mg sine theta, I believe. Yeah, mg sine theta. And theta, again, is 30. It's just a habit of mine to say theta. And then this is going to be mg cosine theta. Cosine 30 degrees. In our negative y direction, which we don't really care about for now. So when summing the forces, this is going to be, let's disregard that. This is going to be mg sine theta. That's our positive part. And then here we're subtracting the frictional force. So to find the frictional force of friction, it's equal to this is kinetic friction, so we're talking about the coefficient of kinetic friction. So force of friction is equal to kinetic friction times the normal force N, which is represented by the N on our diagram that is perpendicular to the slope that it rests on. So here we have N, and then to find N is going to be equal to mg, as it's opposing this force coming down. So we can say force of friction, let's go over here, say N is mg, so we've got this times mg. So I'm going to rewrite this down here so I have some more space. we're summing the forces again. Summing the forces in the x direction is equal to mg sine 30 minus our kinetic coefficient of friction, mg, and all of this is equal to ma, because we know, according to Newton's second law, that force equals mass times acceleration. Now we can cross off m's. Again, you can factor this out, you can divide. This is going to be equivalent. So we can start plugging in numbers now. So let's see. Again, what we're solving for is the acceleration. So this is what we're solving for. So let's set this equal. So g is the gravitational constant. It's about, I rewrote this down here. So g is about 9.81, but on the AP test, we're just going to round it to 10. So 10 sine 30 is 1/2 minus our coefficient of kinetic friction is 0.1. So pop that in. 0.1 times 10 is equal to A. So, we're running out of space here. So 5 minus, half of 10 is 5. Now 0.1 times 10 is 1. 5 minus 1 is equal to A, is equal to 4. And there it is. The answer is B. So let me know if you have any questions about this one. It's pretty simple once you gotta know how to solve for the force of friction using our kinetic, the coefficient of kinetic friction times normal force. Finding normal force, you just gotta know N equals mg, the force that's exerted on the surface. That's Newton's third law. So once you do that, it's a pretty straightforward problem. You just sum the forces, simplify, and there you go. Thanks for watching. Check back in for next video.